Hello, and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video. All math-based, of course, and as always, it is an honor and a privilege to be serving you here, as it is every day in my virtual classroom. Come on, step on in. Integrated Math 1, folk. We have a practice test to look over, to review for the unit on functions and sequences, and it's time to take a look at that one. Got a front-to-back worksheet right here. If you want to do it with me, you can download the PDF in the description section below, as well as find the timestamps for any particular problem you are looking for in that description section. Give me a sec, quick sip of water here. Before I begin, I already need water. Oh, good lord, might be a long one. I'm not planning on making this a long video. You know that I can explain things. That's what I want to do. That's the whole point of the practice test, not just doing the problems, but teaching the ideas behind them. But if I do everything right, I shouldn't be eclipsing an hour. I sure would love not to in some ways. Behind me here is the National League Championship Series Game 7. Now, this is being recorded on Sunday night, and you probably wouldn't see this until as early as Monday anyway. So you probably already know the results of this, and I'll let you know a couple things here before we start the math. Number one, I did stumble upon the results of this thing here. And for those, my students who know me either know, they know whether I'm a Braves or Dodgers fan already. But, so I'm going to hide the poker face for either of like whatever the results are. Number two, I hate being spoiled things. Now, I was accidentally spoiled by stumbling upon a text from notifications that I turned off from someone who I didn't want to get spoilers from. But what I did was I entered my text message phone area to send a text to somebody else, and there it was right in front of me right there. So I'll just let this thing play in the background. You can watch what you want. The score right now, Dodgers are up 4-3 in the top of the 8th with one out, and the Braves up to bat. What's going to happen? Let's find out. All right, but let's start some math right here. So the reason I said the spoilers thing was to any of my students, and I haven't mentioned this to you guys, to any of my students, if you ever spoil something for me when I ask you not to beforehand, I will go out of my way to personally find ways to fail you. I've done it for students for Infinity War. You think I haven't done it? I did it for students for Infinity War. I went out of my... No, I didn't actually do that. What I did do, though, was a student was like, please, I have like 52% of the class. Can you give me a D-? And in the back of my mind, I'm thinking, this kid personally went out of his way to spoil Infinity War for me. He meant to do that. Do you think I want to give him a D-? 52%, you're not getting a D- anyway. All right, let's go ahead and get started. Enough of that. Okay, so this stuff is on functions and sequences, which sequences, we're talking about arithmetic, almost for the most part, only arithmetic sequences, at least when it comes to writing a rule. We could use a rule in another fashion to do certain things, but those are discrete functions with a limited domain starting from 1 and go into 2 and 3, etc. We'll get into it when we do. Let's get started here. Number one, what's the value of f of x equals 4/7 x plus 2/3 if x equals 14? They could have also asked you, what is the value of f of 14 straight up? Reason I'm mentioning that is because if you're tested on a question like that, you'd want to know what that means. It means the same thing. What is the f of x means y. So they're asking, what is the value of y when x equals 14? And that's what we're doing. We're going to substitute 14 in for x and figure it out. So 4/7 times 14, parentheses, when in doubt, use your damn parentheses, plus 2/3. Now, 14 does mean 14 over 1 in this case, and when you multiply, you do, I have a tickle in my nose, I'm sorry. When you multiply, you do multiply straight across, so 4 times 14 and 7 times 1. Ordinarily, what I like to try and tell students is that 14 is dividing by 7 just as much as it's dividing by 1. It is. 14 is divided by 7. So if you can do that division, or if you can even reduce it from what it is, go ahead and try and do so. 14 over 7 reduces to 2 over 1. So now on bottom is just 1s. Basically, I can just ignore those. All that's on top is now 4 times 2, and 4 times 2 is 8. So you could do 4 times 14. If you want to do 4 times 14, that's 56. 56 divided by 7 is 8. It still gets you there. Anyway, so we have 8 plus 2/3. Now as a mixed number, that's 8 and 2/3. As an improper fraction, you do denominator times whole plus numerator. Denominator times whole is 24. 3 times 8 is 24, plus 2 is 26. That's 26/3 as an improper fraction. Either or works. I don't want to convert to decimal because I'd have to approximate it or put the repeating sign. I really don't like to do either, and they didn't ask us to do either there, so I'm not going to. I'm just going to write 26/3. That's in general these days we do a little more improper fraction business. Mixed numbers accepted though. That's fine. As long as you reduce the fraction either way. Okay, number 2. A pool is filled with 500 gallons of water. Each minute after that, 50 gallons are poured into the pool. Write a function in terms of W of t that represent this situation. Now, W of t, they didn't tell you what's what here and what we kind of need to find. What we don't know right now is in total how many minutes have passed by and how many gallons of water we have inside the pool in total. Don't just say 500. Remember, we pour 50 a minute after that. It says, 50 gallons a minute after that. We don't know how many minutes, and depending on the number of minutes, we'd have to know the number of gallons of water. W is going to be the amount of water in gallons right here. This is going to be W of t because the amount of water is a function of time, and time is the number of minutes that occur. So you need to see the things that you don't know, identify them as your variables to determine which one's the independent and dependent based on that. If you want to look a little bit more on how to label independent versus dependent when they don't give you enough information like this, check out my last Q&A video and find the question on, I think it's the first question, how to write word problems. And there's a part where I really talk about units, unit alignment, and that might help you. So WT is like your Y and T is like your X. This is like your Y equals blah, 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 blah. Now this is a linear function in that there's a constant rate of increase right here. 50 gallons are poured into the pool every minute. And then you start with 500 gallons. So let's start with the 500 portion. W of T, the amount of water after a certain amount of time, already has 500 gallons of water to start. Now this amount of gallons is going to be in the water no matter how many minutes pass by. You could be 0 minutes, you could be 100 minutes. No matter what, there are still 500 gallons of water in there. So add 500 to the end of whatever you have. This is like a constant amount here. It gets unaffected by time. What does get affected by time is the 50 gallons. Sometimes I see people just put 50 plus 500. No, the answer is not just 550. That would be true after 1 minute. But it would be 100 after 2 minutes, or 150 after 3 minutes, or 0 after 0 minutes. You got to multiply 50 by the amount of time that we're talking about here. Make sure your t don't look like that plus there. Nice and curved, a little bit taller. There we go. W of t equals 50t plus 500. This would be the equation for this guy here. And if you're really not sure how to do these, and this is not something that I mentioned in the word problem thing Q&A video. I should have. If you're not sure how to write it out, try and use real numbers to make sense of it. Say, how much water would there be after 4 minutes? What did I do to get that? And think about it in those terms there. But there it is. W of t equals 50t plus 500. W of t, once again, is the amount of gallons of water, and t is the number of minutes that have passed. Try and plug in some numbers, see if it makes sense to you. Okay, number 3. Which function situation would have a discrete graph? Circle all that would apply. Now, we're talking about either discrete versus continuous. So some people still don't really know what discrete means. But if you know what continuous means, then you know anything that's not continuous, in our cases that we're referring to, would be discrete. Discrete kind of means, like I'll graph something right here. Discrete means points with, skips in them. We're not connecting them. There's not every instance in time where something happens, blah, 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 blah. Specific gaps. Continuous means you would connect those points and have a curve or a line that would go like that. So at every instance of X, you'll get some instance of Y throughout that entire domain. Like everything. All right, amount of milk in a container. Now what this means is, could you disperse any, just like the pouring water in the last example here, I can pour out fractional amounts of milk, little bits of milk. It can drain slowly and progressively. It doesn't disappear like. Now, they don't say over time. They really should. They should say as a function of the number of seconds that you're pouring milk or filling it up or, milking a cow, whatever it is. This one is not discrete. This one is continuous because the milk would continuously, drain. If this is the height of the milk carton over time, it would drain over time. It wouldn't be, here's milk and then there's milk, and it just disappears before your eyes and you go, oh my God, where'd it go? So this one is continuous. I'm just going to write underneath it, continuous. Part B, number of eggs in a carton. I remove an egg. Now there is 1 egg less than there was before. It went from 12 to 11. Yeah, I continuously pull it out, but that's not like half an egg is in there, a quarter of an egg is in there, the whole egg is out now. it's not fractionally done like that. You have 1, 2, or 3, or 4 eggs. You won't have half of an egg in there. So this is discrete. This is an example of discrete. I shouldn't put continuous like this. I was just saying that I'm comparing one versus the other. Indeed, this is discrete. Filling a gas, filling a tank. Same thing, kind of like the milk. It's this fluid progressive flow of something that happens there. You can even see it on the gas readings on your on the tank, right? It doesn't just say boom 1 gallon, boom 2 gallons, and like it just appears in there. This is also continuous in that same fashion. I'm just thinking real terms that like something that's liquid has this progressive flow, these fractional amounts. Eggs are a solid and it's a 1 or a 2. Floors in a building. You're on the first floor or second floor or third floor or fourth floor. You're not on the third, 3.5, fifth floor. Yes, you can progressively go up in an elevator and you're halfway between floors 3 and 4, but the floors of the building, you're on one or the other, or you're not on one or the other. There's no... I understand elevator height might be a continuous. This is discrete in the way that it's the floors. Floor 1, floor 2, floor 3. We list them as such. Okay, number 4. Oh, so that's discrete. Number 4, sketch a graph to represent Mary's situation. Mary walked to school for 5 minutes. She then ran for the next 10 minutes. She stayed there for a meeting. Then she ran all the way home. Mary. If you run in at someone, you be scary. All right. She walked to school for 5 minutes, ran for 10, stayed there for a meeting. So how about 5 minutes in? 5 minutes in. Home. They probably mean distance from home. So she starts at home, I guess. I don't know. It doesn't say where she starts, but I'll pretend she starts from home. She's walking some speed, not too fast just yet, walking some speed. And then for the next 10 minutes, from 5 to 15 here, she goes, holy moly, I gotta run to that meeting. I'm gonna be late. So she goes a lot faster there. Her distance from home is increasing over that amount of time. Now she's at school. Let's say this is school distance from home. Now she's at school and at a meeting. I don't know how long it lasts. It can't last too long, otherwise I'm gonna run out of room here. Is that the meeting for, say, that long? It doesn't say how long. But then she ran all the way home. So she goes all the way back her distance. Whoa, she's sprinting, Mary. Going all the way back home. Boom. Lands at home at that spot. There you go. So there are some critical points right here from her walking to her running. Going faster. Staying the same distance from home because she's at school. And, mad dash home. The rest of the way. Looks good to me. That's continuous, by the way. Over time, you can measure any point that she's at. The graph to the right shows John's distance from home over time. This is number 5. What is happening at the part of the graph labeled B? So kind of same thing as Mary's thing here. John's distance from home increases over time during this thing. What is happening at the part of the graph labeled B? John is going fastest from home at this time compared to any other time that you see here. Maybe this is the walk and the run and the meeting, just like Mary. So part B is fastest speed away from home. I can't say specifically here because I don't know whether he's walking or driving, and then if he's walking, I don't know if he goes from a walk to a power walk or a jog to a sprint. I don't know. His fastest speed away from home, meaning distancing himself away from home, occurs at part B. Okay, number 6. What is the common difference between terms of the sequence a sub n equals 7n plus 11? Now, this one kind of becomes the antithesis of creating the equations in this same exact form. Now, if we're looking at some sort of f of n graph right here, or f of n sequence right here, this is the same thing as a sub n. A sub n and f of n are equivalent. When we've created equations in this format, you might have noticed in our first equation that we wrote these in, it would appear as something like this. F of 1 plus d times n minus 1, value of the first term plus common difference times n minus 1. And when we clean it up, it kind of looks to be in this form that you see here or here. Now, d, when it distributes with the n, you can see that you get a term eventually that says d times n. Whatever's multiplying with n is d. That is your common difference. And if you're uncertain of that, you can start trying to build some terms and see if it works out. What is the value of the first term? That's 7 times 1 plus 11, which is 7 plus 11, which is 18. What's the value of your second term? That's 7 times 2 plus 11, or 14 plus 11, which is 25. What's f of 3? I'm just going to do this last one. 7, value of the third term is 21 plus 11, that's 32. You can see that the difference between these numbers here is 7, and in an arithmetic sequence that makes it a common difference here. So your common difference d is 7, which again appears to be this number that is multiplying with the n being the position of your term, and that's what arithmetic sequences do. They use the position of your term to figure out the value of that specific term there. And that's what we're getting there. Now, only arithmetic sequences feature a common difference, so you'd have to kind of know it's an arithmetic sequence before you proceed on that. Okay, number 7, what is the value of f of x equals x squared minus 1 when x equals negative 8? This one's not a sequence because now we're using negative domain portions, but either way, this is very much just like problem number 1 here. We're going to substitute negative 8 in for x. F of negative 8 equals, the one thing here, definitely when in doubt, use your damn parentheses. You really want to substitute the negative 8 into here with parentheses, because when we square a negative 8, we need to make the positive 64 that it is. So this becomes 64 minus 1, which is 63. So f of negative 8 there equals 63. If you get negative 65, that's because you squared a negative 8 and got negative 64. Not what should be happening here. Not what should be happening there. If there was a negative in front, yeah, then we get the negative opposite, blah, 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 blah. That would be negative. Yeah, that would work out. But that's not what this is here. All right, number 8. What is the range on the relation shown on the mapping diagram? What's the score by? Oh, commercial. Check the score later. What is the range on the relation shown on the mapping diagram? This is your domain. This is your range right here, okay? Domain is on the left. Its x is pointing to y. Let me just say, I'm going to spell this out in greater detail depending on the question that's asked to you. Dodgers still up 4-3, bottom 8-2 out. All the coordinate pairs that are on here, guys, just so you know, negative 8, 7 exists here. Just watch where the arrows point. Domains are your x's, ranges are your y's. Negative 1, 9 exists. 0, 9 exists. 15, 7 exists. And 15, 9 exists. Again, 15, 7, 15, 9. This is not a function because of that repeat x with different y's there. Or you can see, once again, the split from your domain elements to range elements. Not a function. Not what they're asking. They even call it a relation to make sure they're not calling it a function in that regard. Making sure you know what all this stuff means, how you write them out. By the way, you can have duplicate y's. I shouldn't use red. You can have duplicate y's with different x's there. That's totally fine, and have it be a function. They are asking for the range, though. This doesn't help me get the range any better than what I'm looking at right here. The range values here are simply 7 and 9. Just spelling it all out. You need to know what a type. I was going to say a mapping diagram. I was going to say diaper. Mapping diagram is, how you use it, what you can infer from it, and of course where you find the domain range. Domain's on the left, points to the range, range is on the right. Write in increasing order, avoid duplicates, but a mapping diagram already does that. Okay, are we already halfway done with this thing? Man, this should be just fine. What is the 7th term in the explicit rule of the function a sub n equals n squared over 3n? Okay, last time I didn't use subscript notation, so this time I will. When they ask for the 7th term, we are talking about when n equals 7. They want to know its value at this position. So we are going to just go ahead and substitute 7 into here. A sub 7, by the way, it means the same thing as f of 7. F of 7, a sub 7. Equals, and substitute 7 into this guy. 7 squared over 3 times 7, just like that. There are ways to clean this up faster than what I'm about to do. Well, I'll consider showing you the alternative after. 7 squared is 49, and 3 times 7 is 21. You could end it here, but I certainly wouldn't if the fraction can still reduce, which it can. We can divide both top and bottom by 7. Divide top and bottom by 7 here, and you get 7 over 3, or 2 1/3. That is, dividing 7 by 3, you get 2 wholes, and the remainder is 1. So 7 thirds or 2 1/3. I'm going to stick with the 7 thirds, like I've done before. especially if this was some sort of recursive rule, which is not. It's easier for me to go from one number to the other just by calculating from an improper fraction. Now, I could have gotten 7/3 a little bit easier here because 7 squared also means 7 times 7. And there are two multiples of 7 that exist on, or there's one multiple of 7 that exists on top and bottom here. 7 over 7 is 1. They cancel. You're left with 7/3 right there. If you notice it, you can use it. All right, 7/3 is that answer on number 9. Let's keep moving forward. Number 10. Is the relation shown in the table a function? Why or why not? Okay, this kind of goes back to the thing I mentioned in the mapping diagram stuff. Now, whether or not we draw this, I might as well do a mapping diagram with you on this one, as well as ordered pairs. There are ordered pairs 3, 4, 5, 5, 7, 5, and 9, 4. Okay, all right, to get things off the bat here, it's okay if x's and y's duplicate together. If you have 5 with 5, that's totally okay. And as I mentioned before, it's totally okay for y's to duplicate with different x's. 2 5s with different x's and 2 4s with different x's. That's allowed. The question is, do we have duplicate x's with different y's? That answer is no, we don't have duplicate x's with different y's. That's a good thing as far as functions are concerned. As long as there are no duplicate x's with different y's, it is a function. So this one indeed is a function. If you want to look at a mapping diagram or if you want to draw one out, here's what I would do. It's got to be very small. I'm sorry. Here are my domain guys. Those are the x's. Here are my range guys. Those are the y's. Write your domain values in increasing order. Avoid duplicates. 3, 5, 7, 9. It's already there. 3, 5, 7, 9. The range values are 4 and 5. Avoid duplicates. Increasing order. 4, 5. And the way you map it looks like 3 goes to 4. 5 goes to 5. 7 goes to 5. And 9 goes to 4, like that. Once again, the mapping diagram, no single domain element goes to 2 different range elements, but 2 different domain elements go to single range elements. That's fine. This one is totes a function right here, guys. That's totally allowed to do. We are good. Right, number 11. Write y equals negative 5x plus 4 in function notation. Let y be the dependent variable. Function notation means some sort of f of x right here. And I specifically want to use x because x is right there. You can use f of x, g of x, who cares? We're going to use f of x a whole lot. So all you got to write is f of x equals negative 5x plus 4. Not much more to say on that. Y and f of x are the same thing, assuming that your equation is already a function. If it's not a function, you would never use f of x in the first place. But if they're asking us to use function notation, golly, this must be a function. And what is a function? Only one y for every x. If I plug in some x in here, I better not get multiple answers for y, and I don't. That's good. All right, number 12, Kyle bought a car for $52,000. Nice, Kyle. Each year, the value of the car decreases by $1,800. Write a function that shows the value of the car after X years. Okay, so the value of the car depends on the number of the years. The value of the car is a function of the number of years that go by. So function f of x that shows the value of the car, f of x is representing just that, the value of the car. So the value of the car is determined by, and actually I'm going to kind of rewrite it here afterward. The value of the car starts at $52,000, essentially at year 0 when he buys it. And then every year it loses $1,800 in value. So I subtract $1,800 every year that passes by. When you multiply 1,800 by the number of years, that shows you how much it has depreciated. If 10 years go by, 1,800 times 10 is 18,000. It would have lost $18,000 in value, and it would be $34,000 in value total because you put 10 in there. Same kind of thing. Now, I'm going to write that in here right now. Only thing I'm going to do differently. This is something you're like, why'd you do that? Just because. It's standard form. I'm going to write the x term first. I'm showing you that you can do this as well. Most people are like, I don't like negatives in front. Sometimes I don't either. It depends on what it is. This is that whole mx plus b look, though. You're going to see this a whole lot. These are off the starting value. You just write last just because it's just a constant amount, you know. This is the other part that's there. But anyway, it's negative because it's losing. It's decreasing. Decreasing and losing. Okay. Braves had 2 more outs to work with. Will they get it? We'll find out. And if they do, will they hold the Dodgers? We'll find out. Or do they go extra innings? We'll find out. Maybe I'll finish this before that. Number 13, graph the function y equals negative 3x plus 1 for the domain negative 4, negative 2, 0, and 2. Okay, first of all, if this wasn't here, even if they gave you a table with these values, to plug in as suggestions, if this wasn't here, then that means that this graph would be continuous and we would assume an all real number domain. That means even if we plotted these points here, we would connect the dots. Now, this was here. And they say for the domain, which means we are restricted to this domain. These are the only values we can choose, and this graph will be discrete. It will be discrete for that kind of very reason. They've restricted our domain. These are the only points that can exist. So I can create a table. X, I'm going to show the work in between here, and then we'll get the y values out, and then I'll plot those points. Sorry if number 15 kind of gets in the way here. So negative 3 halves x plus 1. You don't have to do this necessarily, but it's probably a good thing to, to do. If I plug in an x and get out a y, I'm going to plot those points there. Let's check it out. Oh, Dodgers won. They won the National League Championship Series. They are going to the World Series. If you haven't realized by now, I'm a Braves fan. So boo hiss at that. This is one of those things where if the Braves went, if they won the World Series, I'd say this season counted. But with the 2020 pandemic, stuff like that, to me, this MLB season now, especially since it's just the Dodgers that are in. I hope the Rays beat them in the World Series, by the way. But now that the Dodgers are in, I'm sitting there going like, the season doesn't count anyway. Braves choked. They did. They were up 3-1 and lost 3 games consecutively. And golly, the game where they gave up 11 runs in that first inning was no fun anyway. All right, let's continue on. I've already felt rage from it. All right, let's go ahead. We're going to substitute negative 4 in for x. Negative 3 halves times negative 4 plus 1. And then negative 2 and 0 and 2. Let me actually start with 0 just to make this easier on ourselves instead of all the negatives and stuff. Substitute 0 into here. Negative 3 halves times 0 is 0. 0 plus 1 is 1. So there's a point on the graph that's 0, 1. I'm going to plot it right here. So that's what it is. Plug in a value for x, get a value out for y. Let's go to 2 next. Sorry, I'll do the negatives after. I just don't want you to feel too bogged down by negatives. All right, negative 3 halves times 2. Now, this is one of those things, once again, like that 14 and 4 that I talked about before. Negative 3 times 2 is negative 6. Negative 6 divided by 2 is negative 3. Negative 3 plus 1 is negative 2. Now, you could also, although these numbers are not big, and you probably don't need to mess up on it, you could have just done 2 divided by 2 to get 1. And then negative 3 times 1 is also negative 3. Right, so you can do either or with that. You can either divide the 2 by this 2 first or multiply it by the negative 3 first. Either way, both things will happen at some point. So just keep that in mind there. On that note, let's just do the negative 2 next because that'll just be the opposite of what the positive 2 was there. Negative 3 halves of 2 was negative 3. Negative 3 halves of negative 2 is positive 3. Right? Negative times negative is a positive, but the same numbers hold in. So that's 3 plus 1, which is 4. Oh, 2, negative 2, by the way, goes here. Negative 2, 4 goes here. All right, negative 3 times negative 4 is 12. 12 divided by 2 is 6. 6 plus 1 is 7. Or like I said, you could do negative 4 divided by 2 first, which is negative 2. And negative 2 times negative 3 is positive 6. Once again, plus 1 is 7. So negative 4 comma 7 exists right here. Now this does have a linear path, as all arithmetic sequences would do, as all linear functions do, these things with this constant rate and slope. But we are not going to connect them because this is a discrete function because of the restricted domain. And there it is. You're done with that graph. They restricted our domain. It's not because the inputs they asked us to choose. It's because they said this is the domain. These are the only x's that exist on the graph. Remember, when we connect the dots like that, that means you're telling them that this point exists on the graph, and this does, and this does, and this does, and this does, that all these are x values we could have plugged in to get values out for y. We're not allowed to. They didn't give us that opportunity. Okay, number 14. Why do you not connect the points on this graph? Okay, so I've been talking about this, so that's what I get for not looking at the practice test before doing it. Yeah, guys, this is a limited because the domain was restricted to only -4, -2, 0, and 2. This function is discrete. I probably should have mentioned that part first. Because this function is discrete, whatever. I'm just lending to the point that discrete does not connect. Okay? All right, number 15. For the function 7, state the domain, state the range. Not going to get into the whole mapping diagram, this and that, because mapping diagram requires domain and range anyway. So domain here, the x's in increasing order without duplicates. I have the numbers 7, 1, 3, 3. I'm not just going to write 7, 1, 3, 3. In fact, I'm going to write 1, 3. I just totally wrote a 7 when I said 3. 1, 3, 7. You know what's hilarious is if I did write 1, 3, 3, 7, gamers might appreciate this. All right, gamers, what does that mean? You guys know, come on. Anyway, it's 1, 3, 7. No duplicates, increasing order. Boom. Range, increasing order, no duplicates. The numbers I have are -2, -5, -4, -8. Okay, so all negatives. Now remember, negatives are always smaller than positives, but larger negatives are smaller than smaller negatives. Now that might sound weird. What I mean is -100 is a lesser value than that of -1. -100 is further negative, therefore it is more negative, therefore it is lesser. So when we write increasing order and they're all negative, find the largest negative and actually go downward to the smallest negative. So -8 is first. -8 is first there. And then -5, and then -4, and then -2. As we get closer to 0, the numbers are actually increasing in value. There it is. No repeats, by the way. All right, number 16, graph the function y equals x squared plus 3. Now they give us 0 inputs here, and they don't restrict our domain. That means we got to be a little bit creative and consider our own domain. I tell my students to give me 5 points, or as many points as you can fit, whatever it is. In these cases, some negative, some positive, and 0. Hey, how about that? That'll probably work out. Give me 5 points on this graph here. Oh, let me not just do an XY. I really want to keep plugging these in to plug along and make sure that other students who are practicing this know what the heck they're doing. So here we go, x squared plus 3. When I substitute these things in, I got -2 quantity squared plus 3, -1 quantity squared plus 3, 0 squared plus 3, 1 squared plus 3, and 2 squared plus 3. Notice I'm using parentheses each time out. I didn't have to for these 3, but I do have to for these 2. -2 quantity squared is 4, whereas just a -2 squared would be -4. We want this to be a positive. And 4 plus 3 is 7. Let me change the color on this guy. Let's make it green so it stands out. We're almost done with this, guys. How far have I gone? Just 33 minutes. -1 squared is 1. 1 plus 3 is 4. 0 squared is 0, plus 3 is 3. 1 squared is 1, plus 3 is 4. Hey, I've seen that 4 before. 2 squared is 4, plus 3 is 7. Hey, I've seen that 7 before. Yes, parabolas have this bit of symmetry to them. And it's going to kind of look a little bit like this. We got a U shape going, and yes, we are going to connect this. They did not restrict our domain, so we do connect the dots. This is continuous and an all real number domain we got going on right here. Love it, live it, want it. Now, I was kind of, I've mentioned before in the past, don't make this go straight vertical. I kind of nearly did, but I don't think that's too penalizing, I think. Integrated Math 1 students won't know too much about quadratics until they hit Integrated Math 2 anyway. Just get the points you're supposed to find and make sure that it goes in properly. Now again, there's that symmetry right here, and this is a function. This passes its vertical line test. Even though they're the same y for different x's, that's allowed. You just can't have something like this, 2 y's for the same x. That would not be a function, and they state it's a function here, by the way. All right, what is the value of the function in number 16 when x equals 2? Now, we already got that. The value is 7. So f of 2 there is 7. You substitute 2 in for x, you get 7 out for y. Thank you for giving me something I already answered. Number 18, find the next two terms of the sequence 2, 5, 10, 17, 26. This is where you do want to probably apply some sort of recursion. Figure out if you can sense some sort of pattern. Either maybe is it multiplying by something over and over, or is it adding something over and over? This is not arithmetic because it's not a common difference, but let's look at these differences and see if you can note anything from it. Because I don't know what 2 times 5 is in terms of multiplication. I mean, I do, but like it's nothing that I think I'm going to care about. Plus 3, plus 5, plus 7, plus 9. If you can notice, the next successive odd value is being added to the previous term. So now I take the previous term, 26. I'm probably going to add 11 here once you kind of see that pattern. 26 plus 11 is 37. And then 37 plus 11 comes, or plus 13, excuse me, comes next, and we should get 50 right there. So 37 and 50 should be the next two terms in the sequence. This is not arithmetic. You would not be making a rule with a common difference or anything like that. In fact, we're not going to make a rule for that. There is a way to do it, but we're not dealing with that. However, here we will. Number 19, last one. Write an explicit rule for the sequence 3, 7, 11, and 15. This is an arithmetic sequence because it does feature a common difference. If you haven't noticed here, 4 is being added each time. If you don't know what's being added, take one term minus the one before it, like 7 minus 3, or 11 minus 7, or 15 minus 11. You can do that. I could have done that in the previous one as well, but it wasn't a common difference here. This is 4, 4, and 4. Your common difference here is 4. You're also going to need the value of the first term here, f of 1. By the way, we can also write that as a sub 1 if you're really interested in doing that. And that first term is 3. That's the value. So the formula looks like this guy right here. To find the value of term n in explicit rules, it looks like this for arithmetic sequences. Take the value of the first term and add the common difference times n minus 1. Or, of course, in subscript notation, it's a sub n equals a sub 1 plus d times n minus 1. No difference. No difference in the two. You are just writing it out, just plugging in f of 1, plugging in d. And then we should simplify it to make it look like those other ones, like the, I'll show you what they are. All right, here we go. So substituting, plugging away, I'll use f of n this time. So f of n equals, f of 1 is 3, that's the value of the first term, plus the common difference of 4 times the quantity n minus 1. Let's go and simplify this guy. Distribute, and I have 3 plus 4n minus 4. Now, 3 minus 4 is negative 1. These two here are going to combine. 3 minus 4 gives me negative 1. I don't know what just happened there. So that's a negative 1, and here I have a 4n. So 4n and a negative 1. 4n minus 1 is my guy here. I'm going to write it right here. f of n equals 4n minus 1. Keep in mind, we started here, and I simplified it to get there. So see, this does look like all the other ones that you often see, and 4 is still that common difference that was mentioned before. So the number that multiplies by n is indeed that common difference. All right, this practice test, look, it felt relatively easy compared to that of some others that you might be running into. I'm not saying that the material's easy, or the information's easy, but the practice test itself seemed to be. And so if my kiddos are testing, then hopefully this was pretty easy as well. Kind of short. All right, so that ought to do it for this one, guys. This is Mr. Robinson here, and I hope you do enjoy your evening and the World Series, even though the Braves aren't in it. Take care.